Hello, my dear children. I hope you're all safe, healthy, and smiling today. So, welcome back to our physics class. Today, we are going to start a beautiful chapter that is gravitation, the force which keeps us on the earth and guides the motion of planets and satellites. So, here we begin with the new chapter that is gravitation. So, before beginning with the chapter, let us try to understand the basic term orbit. So, what is an orbit, children? As we know that all the planets revolve around the sun in some path. Similarly, all satellites revolve around the planets in some particular path. And this path along which the planets revolve around the sun, or the path along which the satellites revolve around the planet, this path itself followed by the planets or satellites is called as orbit. The path followed by the revolving planets or satellites is called, while revolving, is called as your orbit. I hope you understood, children. Well, the path followed by planets while revolving around the sun or satellites while revolving around the planets itself is called as an orbit. So, generally, this path is taken as circular orbit. According to Newton's first law, we know that, so there must be some force of attraction between any two particles. Okay, so these planets and satellites can move around the sun or planets because of some force of attraction between these two, and this is governed by Newton's first law. And this phenomenon is completely explained by the person Sir Isaac Newton while observing apple falling from a tree. This gives the complete clarity how the binding between the planets and satellites and sun is being formed. So, what he observed is, so this person Sir Isaac Newton once observed the free fall of apple from a tree. So, what he observed was an apple fall from the tree onto the ground. So, what force is acting to make the apple fall down is nothing but the gravitational pull of the earth. The gravitational pull of the earth makes the apple to fall down from the tree to this surface of the earth. Okay, so that means there must be some attractive force acting between an apple and the earth, between two different objects. Similarly, he concluded that among all the objects or particles in the universe, there must be some attracting force between each other. Okay, so the force of attraction between any two particles or objects, I repeat, the force of attraction between any two particles or objects in the universe is called as the gravitation or gravitational force. So, let me write down the same. So, what is gravitation or gravitational force, children? Either it is written as gravitation or gravitation force. Both means the same. So, what does it exactly mean? Means the force of attraction between particles or objects in the universe. So the force of attraction between particles or objects in the entire universe itself, this force itself is called as gravitation or gravitational force. Okay, so now let us try to understand, and this is told by Sir Isaac Newton. So let us try to understand clearly regarding the Newton's law of gravitation, how he explained the same concept, apple from a tree, with all the particles in the universe. Okay, so what he says is Newton's universal law of gravitation. So let us go in detail regarding the Newton's universal law of gravitation. He says that every particle in the universe, I repeat, every particle in the universe attracts every other particle. Either you say a particle or an object, makes no difference. So every particle in the universe attracts every other particles with a force which is directly proportional to the, product of their masses and inversely proportional to the square of the distance between them. So let me write down the same. So what he says that every particle in the universe attracts every other particle with a force which is proportional to product of their masses and inversely proportional to square of the distance between them. Let us try to understand the same in clear way. So every particle in the universe, for this let us consider two particles. So let us assume those two particles are having some masses as m1 and m2. So this be particle 1 and this be particle 2. So let us suppose that the mass of the first particle be m1 and the mass of the second particle be m2. Let us also suppose that these two particles are separated by a distance r. So what he says is every particle in the universe attract every other particle with a force which is proportional to the product of their forces. So with a force which is proportional to product of their masses. What is the mass? First body mass m1, second body mass is m2. So m1, m2. So this is the first statement. Every particle in the universe attract every other particle with a force which is proportional to product of the masses and inversely proportional to the square of the distance between them. Square of the distance between them. So what is the distance between the two masses? They are separated by a distance r. So what they say is this force is also proportional to, inversely proportional, inversely means reciprocal, denominator, inversely proportional to the square of the distance between them. So distance I have considered it as r. So square of the distance means r square. So inversely proportional to r square. So this must be equation 1 and this must be equation 2. From equation 1 and 2, we can conclude that F is proportional to m1 m2 upon r square. So what is the value of F, children? F is proportional to m1 m2 by r square. If you remove this proportionality constant, then we have to replace it with some constant, and that constant, let us take it as some g. So proportionality symbol is removed, then equal to symbol is kept. So this keeping m1 m2 upon r square as it is, as proportionality symbol is changed to equal to symbol, some constant of proportionality indicated with the letter g. Hence the value of F, the force between the two bodies, two particles, two objects, is equals to g times of m1 m2 upon r square. So very clearly one thing you need to know, children, this mass attracts second body with some force F1 and the second body attracts the first body with some force F2. So let me explain the same clearly, children. So what we are saying is, if you have two bodies given something like this, body 1 and body 2, whose masses are given as m1 and m2 respectively, m1 and m2, separated by a distance r, then this force acting on the second body by first body, the force acting on the second body by first body is given as force on 2 by 1. So it is given as force on 2 by 1, force acting on second body by first body. Similarly, the force acting, this mass, second mass is also attracting the first body. So with how much force is it attracting means some force acting on the first body due to second body given as F12. Force on 1 due to second body. F21 indicates the force acting on the second body due to first body, and force 12 indicates force acting on the first body by the second body. Okay. So as I have discussed that these two are separated by some distance, say r. So moving ahead, so what is the value of force, children? Force between either the first body attracting the second or second body attracting the first. These are equal and opposite to each other. So F is equals to G into M1 M2 by R square, where G is universal gravitational constant, M1 is mass of the first body, M2 is mass of the second body, and R is the square distance between the two bodies. So let me rewrite the formula once again, children. F is equals to G M1 M2 by R square, where G is called as your universal gravitational constant. The value of G, its value is given by the numerical value. It's a constant value. It's a fixed value. So the value of G is taken as experimentally. The value of G is calculated by as 6.67 into 10 power minus 11. How much is that? 6.67 into 10 power minus 11. Coming to the units. Okay. In order to consider the units, and this value of G is calculated by the scientist Cavendish in the experiment, Cavendish experiment. The value of G was calculated by Cavendish experiment. With that experiment, he calculated the value of G as 6.67 into 10 power minus 11. So that experiment you will be learning in the higher classes. Okay. Well, and coming to the SI units, as we know that the value of F is equals to G M1 M2 by R square, and you want to know the SI units of G. So, keeping this G here itself and taking all other values to the other side, then what do you get, children? Bringing this R to the other side, we have F R square equals to G M1 M2. As I want to find out the value of G, I must take M1, M2 to the other side. Then how much you will be getting? F R square by M1, M2 will give the value of G. So, in order to find out the value of G, the formula is FR square by M1, M2. As we want to calculate the units of G nothing but the units of F multiplied by units of distance square divided by the units of mass. So, what is the unit of force, children? Newton. Unit of distance is meter. In SI system, it is measured in meter. Newton. R square, meter square upon M indicates your mass. So, mass is generally measured in kg. SI units kg. So, kg into kg, you will be getting it as kg square. So, what are the SI units of universal gravitational constant, children? It is Newton meter square per kg square. So, Newton meter square per kg square. Hence, the value of G in SI system is given as 6.67 into Newton meter square per kg square. So, this is an important value you need to remember, children. So, what is the value of universal gravitational constant? 6.67 into 10 power minus 11 Newton meter square per kg square. Okay. Well, children, okay. Suppose if in the above equation, here we go. If the value of here, suppose if mass, two bodies of masses, if first body mass, if you consider it as 1 kg, second body mass also if you consider as 1 kg, and they are separated by a distance of 1 meter, then M1 equals to 1 kg, M2 equals to 1 kg, and the value of R is equals to 1 meter. Substituting all the values in the above equation, you get F is equals to G into M1 is 1, M2 is 1 upon R square. R square means 1 square. So, this implies the value of F is equals to G into 1 is G upon 1 square is again G. So, the value of F is found to be G. So, we can define the value of G. So, definition of G can be said as so. The value, the universal gravitational constant is defined as the force acting. Universal gravitational constant is defined as the force acting between two masses. How much mass? Two masses. Two unit masses separated. Unit masses means each equals to 1 kg. So, the universal gravitational constant is defined as the force acting between two unit masses separated by a distance of 1 meter. Two unit masses separated by a distance of 1 meter. So, that we can define the value of universal gravitational constant. Okay. So, children, this gravitational force on the surface of the earth itself is taken as gravity. I repeat, the value of F, the force with which the earth attracts all the bodies. The force with which the earth attracts all the bodies towards itself is called as force of gravity, indicated with the letter, also called as acceleration due to gravity. So, there is a earth surface, earth tries to pull all the objects towards itself in its vicinity. And how much force is acting between the earth's surface and the other body means it's nothing but the gravitational pull of the earth itself is called as force due to gravity, indicated with the small letter G. The force due to gravity is indicated with the letter G. It is also called as acceleration due to gravity. Force due to gravity or acceleration due to gravity. And its value is found to be 9.8. The value of G is found to be 9.8 meter per second square. The force with which the earth attracts all the bodies in its vicinity is called as acceleration due to gravity, and its value is found to be 9.8 meter per second square, children. Also remember that the value of 1 kg weight, 1 kg mass and weight indicates G. 1 kg mg, m is 1 kg, weight means the value of acceleration due to gravity. So, 1 kg weight is nothing but 1 into 9.8 and this is nothing but 9.8 Newton. How much is that? 9.8 Newton. So, now Newton indicates, this 1 indicates your kg, units are 1 is measured in kgs and weight is measured in meter per second square. So, kg meter per second square or simply Newton. So, always remember that 1 kg weight is equals to 9.8 Newton or 9.8 kg meter per second square. Whereas the value of G, acceleration due to gravity, is given as 9.8 meter per second square. Got it, children?